All right, last one. Transform the following network into a computer-ready matrix. So we just want zeros and ones or zeros and numbers. Okay, so we're going to do that right now. But just know, as those of you watching the video will have the advantage of knowing that tomorrow on the test, it will be the other way around. You'll be given a matrix, and you'll have to draw this diagram. Okay, so that's all. It's not a big deal, but it might take somebody off guard if you haven't watched the video. So kudos to you. Okay, now what we have here is we have 10 nodes. Okay, now, so this is a nodal network, okay, or a nodal diagram. And so it has all these nodes, and it has 10. Now it is good to just label this. Okay, we'll extend it a little bit more. Okay, 1, 2. Okay, it's going to be a little tight here. Okay, so we got a very large matrix. Now your nodal network will not be nearly as this large. Okay, I'm not going to give you a large 10 by 10 matrix. I'm just not. Okay, but just think of the computer information here at 10 by 10, 100 pieces of data, just to demonstrate this network. It's kind of fascinating to me. All right, so you just start from 1. 1 to 1, no, there's no loop there. We talked about that before. That would be a 0. 1 to 2 is a 0. 1 to 3 is a 0. 1 to 4 does not go. Okay, so I know I'm doing this quick. 1 does not go to 2. 1 does not go to 3. In fact, he only goes to 8. So I could put one path to 8, and then all the others are zeros. That's all he's got. Okay? The 2, in fact, what it's better to do is to think, well, 2 will go to 8, and that's it. 2 goes to 8, and that's it. Everything else is 0. Okay, so I'm going to go 2 to 8, 1, and also he will be 0. Okay? 3 goes to 2, and that's it. These two arrows actually come from 6 and 4, so it looks like it only goes to 2, so we'll put a 1 there. So it's better to actually think, where does it actually go to, rather than where does it not go to? Where does it go to, and then everything else would be filled in with zeros. We go to 4, 4 only goes to 3. 5 only goes to 4. 6 goes to 3 and 5. Okay. What's really cool about this is that this matrix can be multiplied and like for example, like what is it going to cost? Like you could have a multiplier that if you're going to travel from 1 to 4, what are the possibilities of the fees? Like I could multiply by each one of the fees that it takes to get across, right? So when I multiply by that, we didn't have enough time to get into it, but if we multiplied by it, like you could calculate what is the cheapest way for you to get from 1 to say 4, all right, by multiplying by the prices of each route, each of the routes, each of these lines. And then you can say like, well, what is the cheapest one? I can go there because there's many possibilities that I could probably take to get to 4, to 4, okay? There's no, in this case, actually, there might only be... Okay, that was a bad example. There are actually 0 ways, I think, for 1 to actually get to 4. That aside, if this was, like a real thing, you could multiply it, and actually get a price. Like you could multiply. Let's say that 2 has a problem with tarding, problems in the where it breaks down, like the buses break down in city 2. So if you have enough data, you can figure out the probability, and then you can actually figure out how long is it going to take for from 1 to get to 4 if you have to travel through 2. It's really, really fascinating. And like I said, people get degrees in this stuff. 7 goes to 8, and it goes to 6, and that's it. Everything else is 0. 8 goes to 9 and 2. Okay, really, this is just me developing the answer key. All right, that's it. 9 goes nowhere. Doesn't go anywhere, so this will just be a bunch of zeros. Okay, and then 10 only goes to 9. Everything else will be 0. All right? All right, that's how you would program a computer to actually handle this nodal network. All right, just beginner computer science type stuff. All right, that's it. Stop here and have a good night.